Okay. All right, so again, this is just a bunch of hodgepodge, but yet the other day, whenever we were together before, you remember talking about circles? And so just to back up, 8b, when the center was 5, -4, and the radius was 6, what did we say that equation was? You should have it written down, we did it already.
In the parentheses, x minus 5, and then y plus 4 equals 36.
Perfect. So in the parentheses, go the opposite of the center, right? And then over here goes that number squared. So now you're doing the same thing backwards. Here's the equation. This is 9a. Here's the equation. And you're going to tell me what the center and the radius are. Well, you should be able to do this. What's the center of this? 2, -3. Everybody good with that? Remember, it's the opposite of what's in the parentheses. And then what's our radius going to be? 4. The square root of 16. Everybody see make the connection there between what we did the other day and this? All right, how about the next one? Where's the center and the radius of this next one? Woo, nice job. The center's at -5, 0, and the radius is? Root 7. Now, does everybody get -5, 0? Why is it 0? Because there's nothing attached to it, right? So it's 0. Perfect. Speaking of that, what about C? The origin, 0, 0, is your center. And what is your radius? Square root of 7.
10.
Oh, 10. 7 was this one. Square root of 10. Thank you. All right? Okay. Now, we're going to write using absolute value. Now, this is a little bit different. A little bit different, but I think we can figure it out together. Let's just look at a number line for a second. And let me just put a 5 here and a 11 here. How would I find the distance from 5 to 11? I want the distance. How would I find that, Allie?
Subtract.
I would subtract, right? And I could do 11 minus 5, or I could do 5 minus 11 as long as I put it in absolute value, right? It's a positive number. So the distance between 5 and 11 is the absolute value of 5 and 11 subtracted. Are you on my page with me here? So now it says the distance between x and 3. So think of your number line. You have a 3 and an x, or an x and a 3. The order doesn't really matter. We said the distance between these was the absolute value of the subtraction. So this distance will be the absolute value of the subtraction. And we want that to equal 8. The distance between x and 3 is 8. Distance is the absolute value of the difference. So you're going to subtract your two numbers, put them in absolute value, and in this case, that distance is 8. Now, would it be okay if you did this? Would that be okay? It absolutely would be. Typically, I'm kind of anal about this. I like to have my variables first, but it doesn't make any difference. Either one of these is absolutely fine. distance between x and negative 2, so stop right there. Distance is the absolute value of the difference. So x minus negative 2, the absolute value of the difference. You looked at it right here. That's how we find the distance. We subtract them, and we can do it in either order as long as we do absolute value. So the distance between x and negative 2, I'm gonna go ahead and write it like that. Would that be okay with you? Is more than 7. Is more than 7. So like this one equaled 8. How do I do is more than 7? Greater than 7, there you go. Here's your inequality. The distance between x and negative 2 is more than 7. All right, see if you can do C. The distance between 4 and x is 12. The distance between 4 and x is 12. Oh, yeah.
Could I write that negative 2 minus x?
Mm-hmm. Yep. All right, what do you think? Kira, you got an idea for C?
I put the absolute value of 4 minus x is equal to 12.
What do you think? She okay? I'm gonna put this, but it doesn't make any difference. They're both right. Put them in absolute value, and they're both right. Either one. Okay, try D. What do you think for D? Katie?
I said x minus 5 is less than or equal to 3.
And you had your x minus 5 in absolute value. X minus 5 is less than or equal to 3. Is no more than 3. Is that the right way to write that? Nicely done. That's exactly right. Okay. All right, shifting gears again. Oh my. We're going to write the equation of a circle. Okay, so let's just stop a minute. Write the equation of a circle. We know, for example, I'm making this up totally, but this is what the equation of a circle looks like, right? And this one would have a center at -1, 3, and have a radius of 4. Now, you're gonna write an equation that looks just like that. But the given is that the diameter, and we know what that means, we know what a diameter is. The diameter has endpoints at 3, -6, and 4, 0. Now, I did not plot these points, they're not right relative to each other, that's irrelevant. We got a circle out there that goes through these 2 points, and we need to write its equation. Okay, so what's going through your head right now? Besides, oh, this is a hard problem, Charlie.
To the distance.
From here to here?
Mm-hmm.
How would that help me? Go ahead.
I was thinking it would help you find the center, but I don't know.
Well, the distance formula from here to here would help me, but not find the center. It would help me because that would tell me, let's say I did that distance and it came out to be 10. Then what would that tell me about my radius? It's 5. And when I write my equation, isn't it good to know what the radius is? Yeah, so we could do the distance formula, okay, think back. Well, how does that work? How does the distance formula work?
It's 2x1.
So I gotta subtract my x's. So 3 minus 4 squared plus negative 6 minus 0 squared. You agree with that? So what is that? That's gonna be, 1 plus 36. Did you get the square root of 37?
Yes.
Now this D, I actually put up there, because of distance, but it's really the length of the diameter, right? So the whole shebang is the square root of 37. When I write the equation, I don't use the diameter, I use the radius. So what will the radius be? Square root of 37 divided by 2. Now, it's not a very nice number, but remember, we're in big people school now, so we get weird numbers. That's your radius. Now, what else do I need? If I'm gonna write an equation like this, what else do I need, Meg?
You need the midpoint.
I
which
need
would
the
be
midpoint,
center.
because the midpoint is going to be the center of the circle, right? The midpoint of the diameter. So how do I find midpoint? Well, we talked about this. Gotta keep up with it, Nyla.
X1 plus X2 over 2, Y1 plus Y2 over 2.
Exactly, the average. So 3 plus 4 divided by 2, and negative 6 plus 0 divided by 2. We find the average. We add them and divide by 2. So what is my center? My center is going to be 7 halves, which I prefer to just leave it. But if you wanna write 3 1/2, that's fine, 3.5, whatever. And my y is negative 3. Now you have everything you need to write the equation of this circle. So what's it gonna look like? Nyla. No, 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 I'm getting ready to get mad. No watches, no phones. Okay, we're off the grid when we're in math class. Okay, what's my equation gonna look like? X minus 7 halves, y plus 3. Now here's where things get a little hairy. What's that going to equal? Remember, this was your radius. Meg?
37 over 4.
Perfect, 37 over 4. Because this number, when you write your equation, is r squared. So our radius was the square root of 37 over 2. So when I square that, I get 37 over 4. All right, everybody okay? Good, because you're gonna do another one. You ready to try number B? On your own. And if there is any person or group of persons who would want to come up and do your work on the board for us, that would be great. Never have to come by yourself. Okay, come on, you chicken livers, somebody come up here. Somebody can do this, you can. Do you wanna bring a friend, you wanna do it by yourself? Bring your friend, she can help you. You guys can work with this together. The rest of you are doing it at your seats. midpoint, we add them and divide by 2. Yeah, there's no squaring, we add them and divide by 2. Anybody else get 3-1 for the center? So she's writing her equation, the first part. And what'd you get for your radius? Okay, be careful here. Yeah, perfect, beautiful. Here's the issue. You have 2 2's here, so you're gonna need another 2. Right, no, that's fine. But you have this one and this other one, so that should actually be a 34. You see that? That's left over. Anybody else get root 34 for your radius? Now, if you did the diameter, you got the square root of 136, which if you reduce that radical, it's 2 square root 34. So when you divide it by 2 to get the radius, you just get the square root of 34 for the radius. So when you write your equation, and then we square it, so it's just plain 34. She's got x minus 3 squared plus y minus 1 squared equals 34. Now, I want to make sure everybody's clear on this diameter radius thing. You need the radius. So if you find the diameter, you have got to divide it by 2. So let's say you didn't reduce. Let's say you left the diameter as the square root of 136. That means the radius is that divided by 2. When you square that to put it in your equation, because this has got to be r squared, it would be 136 over 4. And if you take 4 into 136, you get 34. So even if you didn't reduce your radical, you're still going to get the right radius if you do the right arithmetic. Jake?
Will we find the midpoint first and then just use one of the sides of the midpoint?
Absolutely. Now, you gotta be careful, Jake, because in the last problem, that would have been messy because the midpoint was a fraction, had a fraction in it. But as long as they're whole numbers, Jake says, instead of doing the whole diameter, could I find my midpoint first and do that as the radius? And the answer is absolutely. You can always do that. I don't recommend it if you have a fraction here because then you have to do the distance formula with a fraction, which is possible, it's just yicky. But you can always do that. And then of course you don't divide by 2. That would just be your diameter, or your radius, that's your radius. You okay with that? All right, one more thing to do, and then we'll move on to P3. Thank you, girls, for taking that on. All right, so we've got a line segment, AB, and we have the midpoint of it. And in our first example, we have the midpoint is 6,2, point A is 5,1, and we want to find point B. So what's your thought? Yes, Peter?
This is distance formula between A and M and then just double it.
Okay, now remember, if I do the distance formula between A and M, I'm going to get a radical.
And then just be the same math on the other side.
It would be, but how are you going to get the ordered pair from that radical? Let's say this is root 17. So this is root 17. How am I going to get those points? do it, but I think there's a really easier way. Instead of doing distance, this problem's all about midpoint. So could we use our midpoint idea to find those coordinates? Think about it now for a second. We don't know what these are. But don't we know that 6 is the average of these two? So whatever x is, if I add it to 5 and divide by 2, doesn't that equal 6? Does that make sense to you? So when I solve this little equation, it looks like it has to be 7 for the x. And then I do the same thing with my y's. I got 3. So I got 7, 3 for that point. Now, did that make sense to you? Did anybody do it differently? I actually love his idea of distance, but not like the distance one, but more in terms of a vector type thing. Look at this for a second, guys. If I look at my x's, this is what I knew. From 5 to 6, I took 1 positive step, right? So then, to get from here to here, I'm going to take 1 more positive step. So that would put me at 7. Now in my y's, I went from 1 to 2, which is 1 positive step. So I'll go 1 more, and that puts me at 3. So that would be another way of thinking about it, using the idea of distance. So instead of both points together, or both coordinates together, do the x's, and then do the y's. All right, 1 more, do it. Tell me what you get for B. All right, guys. I got -13, -6. Did I get it right? Thumbs up. All good? Okay, super. All right, P2 due Friday. And now we're starting P3. Remember, we got 7 sections in this chapter, so we have a long way to go. Is -1 a solution of this equation? Is -1 a solution of this equation? Okay, so what's your thought on that? How would you decide if it is or not?
Plug it in for x.
Okay, so one option is, like you check your answers, did I get it right? If I put in, what was it, -1? If I put in -1, this should work out. Right? Well, how do you do this? Without a calculator. Charlie?
You have to get a common denominator.
You have to get a common denominator, so between 2 and 6, the denominator will be 6. So we'll times this one by 3. So we have -3/6 plus 1/6. That's -2/6. Is that the same as -1/3?
Yes.
Yep. So your answer is yes. it is a solution, because when I plugged it in, everything worked out great. All right, now we're gonna actually solve, or no, we're not yet, we're gonna solve in a minute. First, we have to talk about which of these are linear equations. All right, so let me first of all tell you which ones aren't and why they aren't. Well, maybe you know. Can you look at these? And some of them are a little tricky, but some of them are kind of obvious. Does anybody see one that you know right off the bat is not? Lauren, are you raising your hand there?
Oh, no, but I can try.
Okay. B? C? C is not linear. What is wrong with it? Why is that not a linear equation?
There's a root.
This is a no. You can't have x under the radical. Now, it isn't so much, Allie, that there's a radical, it's that there's a letter under it.
Oh,
If
okay.
that had been a 2, a root 2, that would be perfectly okay. But we cannot have x under a radical. When we graph something like that, it has an arc shape, not a linear shape. Carol?
Would that mean that E wouldn't work either?
E is not linear because you can't have any power on x except 1. In other words, you have to have a plane x, only a plane x. You can't have an x squared, you can't have an x cubed, you can't have x to the negative 5th. The only power you can have on x is a 1. Meg?
So would that mean F isn't X?
F is not, because you can't have x in the denominator, because, Meg, if I put x in the denominator, that means its power must have been -1, and it can't be anything other than 1. We cannot have x under a radical, we can't have any power on x other than 1, and we certainly, that means we can't have x in the denominator. Now, this one is a yes. This is a yes, okay? It doesn't violate any of the rules. Would you agree with that? Okay, now we get a little tricky. Allie?
D is just an equation. It's not like there's no x there.
It's called an identity. There's not
Identity.
even a variable in it, right? So this is a no, because we need an x. Now, we don't need an x squared, we need an x to the first power. Okay?
Interruption. Is Sydney Woods in the classroom?
Yep, she is.
Please send her to the counseling center.
Okey-doke.
Thank you.
Come right back if you can, we have lots to do. All right, so we need an x. This one is tricky. This is actually a no. Can you tell me why that's a no? It looks like it should be okay. Braden?
The x's cancel out.
They do. And Braden, when they cancel out, what are we left with?
Just 2 numbers.
Nonsense. Because the two numbers would say 7 equals -3, which we know is not true. Right? So that's a no, because basically there are no x's. I'll just say that. You need an x, right? It's kind of like this one down here. You need an x. So all those problems, and this is our only linear equation. Can't have any power other than 1. Can't be under a radical, because technically that's a fractional power. can't have anything in any x's in the denominator, because that's a negative power. And you gotta have x's, gotta have an x to the first in your equation. All right, now we're gonna solve some linear equations. These are all linear equations. Look at them. They don't violate any of the rules. We're ready to go. You've done this before, so I'm gonna have you come up here, either by yourself or with a partner. If you haven't already been up today, I want everybody to have a chance. So if you think you can solve A, get up here. If you want to tackle B, get up here. And C. Would you make sure you're writing large, okay? Make sure you're writing large, you gotta pick it up on the board. I don't like the fractions. All right, let's go. Everybody at your seat should be working these out. All three of them, let's go. All right. Did you skip fourth grade or what?
Remember fourth grade. It's been a little while.
I can remember fourth grade.
You can remember fourth grade.
His name is Mr. Trier.
Who sat next to you?
That I don't remember. I do remember in fourth grade, this Trier was kind of elderly, and some of the kids were just, they were always doing stuff. So they found a praying mantis nest, and they brought it into school, and the eggs all hatched. So the classroom was like full of like millions of praying mantises. Yeah, that was fourth grade.
Wow.
They also, she had a regular path, like she would walk up and down the rows, so they put on a bunch of thumbtacks, and she wore these like old lady shoes, you know, like, I don't know, anyway. And all those thumbtacks got stuck in her shoes, and so she was click, 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 click. No, they didn't go through, they didn't go through. It was strange. Fourth grade, I mean, you'd think they'd be nice, I was, but they were crazy maniacs. All right, so we got 2 for this one, 6/5 for this one, and it sure is. Good, did you just catch that?
Yeah.
Good job. So remember when you distribute in number C or letter C, you're gonna get, keep going, finish it. You're gonna get a minus 8z and a minus 4. We have to be really careful about that. Let's talk, he's finishing up. Let's talk about this one. Okay, some of you shied away from it because I don't like fractions. Well, there's a real easy way to handle this problem. You can't get rid of the fractions. Fractions are part of the problem. But if you want to get rid of this coefficient, I mean, if it were 2x equals 4, wouldn't you divide by 2? So if you want to do that, you could divide by 2/3, but we know that dividing by fractions is the same as multiplying by the reciprocal, the multiplicative inverse. So whoever did this did, and this is beautifully done, they simply said, I'm going to multiply both sides by 3/2, because that will cancel that out and leave me with x, which is my answer. Now, this person cross-canceled 2 into 4, which is fine. Some of you may prefer to just multiply straight across, 12 over 10. That's fine, but that does reduce. So whether you reduce and then multiply, or multiply and then reduce, really doesn't matter. Are you still wrong?
Yeah, well,
Yep, you're still wrong. You're getting closer though.
I'm learning.
You're learning. That's what this is all about. No, that was right.
Okay. So this is
And you know you're the first person to ever make a mistake.
Really?
Yeah, nobody else ever
Just me?
makes a mistake, just you.
You're really bad at that.
Whoever's
No, you're not.
their first time to that deal.
All right, anybody have a question about those three? You okay, Steve?
They had the wrong
That's okay.
Click on start.
11 halves? We good on that?
Yeah.
All right. Have you forged ahead and done the next two?
No.
Well, let's do it. Now, for the fraction phobics in the class, I'm gonna have somebody come up and do, wait, is there an E?
F is E.
Okay, yeah, I'm gonna do F. Just, because of, some of you are so leery of the fractions. What do you think about this? It's got a ton of fractions in it. What might be a good approach? Jake?
You can find the common denominator for all of them and then you can just cross it out.
Exactly. So, when you look at 3, 4, and 2, what would be a common denominator that you could use? 12? Now, kids, could you use 24? There are lots of denominators that you could use. 12 is the smallest one, so we'll use that. But don't get hung up on it. There's lots of denominators that would work. So I'm gonna turn all my denominators into 12. So I'm gonna multiply by whatever it takes to make that happen. Remember that if you're multiplying the bottom, you're multiplying the top, and the top isn't gonna be a distributive. 4 times the whole thing. Now, are all the denominators now 12?
Yes.
So as Jake said, as soon as you get all the denominators the same, you can just ignore them. So now you have no more fractions. Now all you have is 4t minus 4 plus 3t plus 15 equal to 6. And now you can solve it like a regular equation. Now, I made a mistake in there. I think I got it fixed, so I got negative 5/7. Is that okay? All right, let's have somebody come up and do D. Which, yes, it has a fraction, but yes, you can get rid of it. And then let's have somebody do 4A. Now, 4A is not anything different, it's just an inequality instead of an equation. So I need somebody to come up and do that one, that's 3D. And then I need somebody to come up and do 4A, who hasn't already been up here.
You solved 4A with the number line?
You don't need to solve it with the number line, but you can graph your solution on the number line. And then write your answer as an interval, absolutely. So who's gonna do that? Thank you, Katie, you are a friend, you're gonna get solo. I got it, love it, I got it. What are you doing?
I'm doing my notes.
Why is your phone under your leg? It's supposed to be in your backpack. Who is this adorable kid on your phone? Where'd you go?
Yeah. I was like, how did I get it?
Who's that kid on your phone? He's precious.
That's me.
No way,
Yeah.
that was you?
Me and my grandpa.
Oh, you look so cute.
Yeah, my little bowl cut.
Well, okay, put your phone down now. You were so blonde. And it was
Very
like
blonde.
Very blonde, yeah. Okay, let's see, how did Katie do on this, folks? She solved it like regular. It looks like the first thing you did was subtract 3. and then you subtracted 2x and divided by 2. Now, is that okay? What's wrong?
Doesn't the sign have to change?
Well, the sign, the way she did it, the sign doesn't change. Because because of the way she moved things, she had a positive 2x, so she divided by 2, so her sign didn't change. If you did the problem in a different order, or moved things differently, like subtracted the 4x and added the 1, then you would be dividing by a negative 2, and then you would have to switch the sign. Now, oh wait, I didn't switch the sign, that's what happened, you switched the sign. Now, our answers are actually the same. I like to have my x first, she doesn't care. If she put her x first, wouldn't it look like this? Which is the same thing I got when I did it the other order. For these, we'll be writing our answers as intervals. So think about what this looks like graphically. What would the interval notation for that be? This is called the inequality notation. What would the interval notation be?
It would be bracket -2, comma, infinity.
Exactly. The arrow is pointing toward positive infinity, so it's -2, comma, positive infinity, bracket on the 2, parentheses on the infinity always. They have to be in that order or it's wrong. That's the right answer right there. Okay? I don't know what I was doing, but I wasn't doing problem F. How does that look to everybody? Did you get 17 tenths? I think it's okay. All right, very, very good. Okay, let's keep plowing ahead. B, I'm now in number 4, B is a little bit different. Because it's really 2 inequalities in 1. So we had a couple of different strategies like we always do. But I think the easiest way to do this, since there's only one x in the problem, I don't have them over here or over here, which I could. If there's only one x, then I'm just gonna leave it like it is and get that x by itself. So I'll add 2. So my problem has a beginning, a middle, and an end. So I'm gonna add 2 to each part. And then what do you think I'm gonna do? Divide by 3 each part. And here is my answer. Now, you can separate this into 2 separate inequalities, because that's really what it is, it's compound inequality. But if you separate it, you have to put it back together to get your answer. So I think it's easier, just leave it together and solve it, get x by itself, doing what you do, and that will always work as long as there's only one x and it's in the middle of the problem. Now, what is this in an interval? Bracket, 1/3, comma, 3 parentheses. What's the matter with that?
It's 2 different.
No, this is the answer. There is nothing wrong with this. This is the answer, unless I made an arithmetic mistake. This is the answer. All the x's in between 1/3 and 3, and that's what it looks like as an interval.
Do you have to put that, or can you just keep it as like what we have?
If the directions say write as an interval, you
Okay.
have to put that, and they probably will,
Okay.
honestly, because we're trying to get used to writing things as intervals. All right, we got two more of this kind. So, let's see, who hasn't come to the board yet? Okay, Jake, you want C or D?
I'll do C.
All right, so you've got C, and you can bring a partner if you wish, somebody who hasn't already been up. Need you to do it over here to get on the video. And then I need somebody to do this mess, and this is a mess. I will help you if you are scared of this. I will help you with you. Okay, now everybody else is tackling these. Jake's getting a common denominator, so if you're not sure what else to do, get a common denominator. Now, you're just saying it's tricky. What are you doing? Ah, good idea. I think that's a great idea. I think what Nyla is doing with D is great. She's starting to do the distributive property. I would do that first also. I think that's a great idea. When you get done, make sure you write your answer as an interval. That's what I got. Jake and I match. So if you're done with that one, look up here and see what he did. I'll go ahead and, he didn't have to sketch it. I'll just go ahead and do it for those of you that are confused by the notation, the interval notation. He's exactly right. Beautiful. Beautiful. Oh, 8 times what? 8 times 6. Yeah. 48. You're doing great. This hard problem, you're doing great. So Nyla distributed first. Does anybody have a question about that in this last problem here? Anybody have a question about the distributed part?
How'd she go from x over 3 to 2x?
She times every, she got a common denominator. So she made everything into 6s. So this has to be times by 2.
Okay.
And then she kind of did 2 things at once. She didn't write the denominator because she knew they were gonna cancel. But her top would be, this one's times by 2 and that one's times by 6. Right? To put them all over 6. That's what she did. Yep. And then what would Nyla's interval be? Who can tell me? She did a great job with that problem. Make sure you're following all those steps. That's a tough one. Eli, what's her interval gonna look like? She's gonna write her answer in interval notation like Jake did. What's it gonna look like?
Negative infinity, comma, 33 over 13.
Exactly. Put parentheses on both. All right, guys. Thank you. Have a great day. Do I see you tomorrow?
Yeah.
Oh, good. So we can pick up with this tomorrow. Good job. And I will have notes for you tomorrow. Okay. And then the homework is just like in the honors class. So you go.
Yeah, you do too. Really? What room?
Go ahead. I will have that for you tomorrow. Sorry, I'm trying to kill you or you're trying to kill me.